I have no disclosures. So this is continuing on from diameters. This is to measure levator ani muscle stiffness and force with elastometry at 3 time points pre and postpartum. And it's just explore possible contributors to these changes. So this is the elastometer developed at Auckland Bioengineering Institute to measure muscle stiffness changes in the levator ani muscle. And it is a handheld, automated, instrumented speculum which opens in a transverse direction and measures force at varying lengths of displacement over a set cycle. It's got step phases of opening which are controlled by a linear DC servo motor with a handpiece communicating with a laptop running LabVIEW. The instrument trace is visible in real time and shows the opening in speculum from 30 to 50 millimetres at a sampling rate of 100 hertz. And this figure demonstrates a typical trace over one cycle with 10 step phases of 10-second duration. And the step phase is highlighted here. The peak of the step phase is the MVC of the participant. The speculum is inserted intravaginally, and as you can see, the tip is shaped to be wider at the end slightly, and that is positioned against the levator ani muscle, and this has been confirmed on MRI. The force measures on the left side include the total force was calculated with the second order polynomial around the peak force. The passive force is calculated using the intercept line with the peak force on a linear trend line between the lowest values on either side of the MVC, and the active force has been the difference between total and passive forces. For muscle stiffness, which is the graph on the right, the average force and displacement measures were used from the final 1 second of relaxation time per step phase to form a force displacement curve. Muscle stiffness was calculated using the slope of this curve. The focus of these results are on the elastometry measures taken in the second and third trimester and postpartum. All participants were nulliparous with the mean age of 32 years, predominantly European Caucasian, and there were no significant differences found in muscle stiffness in this group. However, there were significant differences in active force between the second trimester and postpartum, with a reduction of 22% occurring. We use multivariate regression modelling to determine the associations with muscle stiffness and active force, with the variables measured at each time point. Passive force was positively associated with stiffness, which became more apparent at each time point measured. Active force was negatively associated in the second trimester, while in postpartum, age and the size of levator hiatal area at rest, which was measured with transperineal ultrasound, were positively associated, while in comparison, BMI and levator hiatal areas at contraction were negatively associated. There are no associations that were significant for chosen variables in active force. In summary, the pelvic floor muscle properties do change during the 3 time periods measured. There was a 22% reduction in active force from early pregnancy to postpartum, but no change in stiffness. And age, BMI, active force, passive force, and levator hiatal areas were associated with muscle stiffness. Just want to say thank you to my funders and the participants in the study.
Thank you. Are there any questions from the audience? Do you have any suggestions or indications as why active force increased or changed over time? Ischemia, any other?
It reduced by 22% from the second trimester through to postpartum, and it could be to do with the changes that occurred through delivery mode. There was a definite difference when we analysed further down the track between caesarean and vaginal deliveries. And there was also for stiffness for those ones as well.
I'll ask you, how did you actually measure the stiffness? Because it's a difficult thing to do, and you said you stretched and then you relaxed.
Yeah, so at each, I'll just go back. At each of those, the elastometer opens over a period of about 1 second. Yeah. They allow them 3 seconds to relax. We then do an MVC, which is timed with a computer with a beep to make sure that they were consistent with it. and then they relax afterwards. So we took the final 1 second of that final relaxation and then plotted a force displacement curve and calculated stiffness from that.
If you relax your device...
No, the device stays open at each aperture as it continues up.
Okay, so if you're stretching it and then you're letting it relax, how are you measuring it? That's what I'm saying. If you relax it completely, how are you actually measuring the force?
I'm not quite sure I understand the question, but at each level, the force sensors are picking up what force is delivered through the sensors or the device.
If you stretch it,
yep,
and you hold it for a second, and then you relax it to let
no, the
muscle...
device is not relaxing. We're allowing the person to relax around the device.
Right. Thank you.
And there was no pain with any of our participants.
Hi, Jeroen from the Netherlands, Leiden. A question, basic question. What's your definition of muscle stiffness? What is the definition of muscle stiffness?
Displacement, force versus displacement with the slope of the curve. So it's the, I'm having a mind blank here. It's the...
Yeah, because are you measuring the active components or also the passive components, or
it's the combined components? It's the force. It's the displacement. It's the displacement of the force. Sorry, I'm having a complete mind blank over your question. But it's the when you perpetrate the muscle or you move the muscle, and it's that force response with the displacement, force to displacement response, and then we're plotting it and we're measuring it from that slope of that curve.
Yeah,
sorry.
I'm not sorry.
I've got it down, but I'm just having a complete...
Okay, we'll talk
blank.
over it later, yeah?
Yeah.
Maybe it's the active component of the contraction and the viscoelastic element.
It's during relaxation.
Exactly. Thank you for your nice presentation. Just to be sure, you say force, but do you say strength or force? Because force is actually strength per second. So did you measure also in time?
We did measure in time. We've got 3 components of force. We've got total force, active and passive force. And they were calculated...
Am I wrong? Okay. I ask you after.
Yeah.
We are a little ahead of schedule, so I might give you a question as well. This gives a very interesting insight into muscle physiology related to pregnancy. How do you see the clinical applications of your technique?
We had it was interesting to see the ladies over the time period changing. They all found the transverse direction comfortable, but they also was, because I got to see them throughout the pregnancy, there was like significant swelling and congestion in the area as well, which I do think may have contributed to the changes that we were seeing. And the different delivery modes definitely had an effect, which were presented here.
Thank you.
I think it really confers with our study using ultrasonography, finding that the levator hiatus is getting bigger, larger, from week 21 to 37. So that really confers with our results measuring the levator hiatus. What do you find with the strength of the muscle?